am Dr. A. Rushi Kesava, Associate Professor of Mathematics, Department of Mathematics, Marri Laxman Reddy Institute of Technology and Management, Hyderabad. Today, already we discussed in class 1 in unit 2 for engineering mathematics. Okay, so already we discussed introduction and eigenvalues and eigenvectors and properties of eigenvalues and some of the problems of eigenvalues and eigenvectors. Previous class we have discussed the different eigenvalues, how to find the eigenvectors for different eigenvalues. In case some eigenvalues are repeated, how to find the eigenvectors. Okay, so after solving this problem, next we will go to Cayley-Hamilton theorem and find inverse and power of a matrix by using Cayley-Hamilton theorem. Okay, so so in previous classes already we solved different eigenvalues and different eigenvectors. So now the eigenvalues are repeated eigenvalues. In this case, how to solve the eigenvectors? Okay, now given the problem, find the eigenvalues and eigenvectors of the matrix. Okay, so now so now first we have to find characteristic equation of the given matrix. Okay, let us assume the matrix by A. Okay, write down. Okay, let the given matrix A equal to 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. Okay, let us assume the given matrix be A, capital A. Now find the characteristic equation of the given matrix. Okay, so first of all, the characteristic equation of the matrix A equal to det of A minus lambda I equal to 0. Okay, det of A minus lambda I equal to 0. So now we can write the matrix A minus lambda I, det of, that is det of 6 minus lambda minus 2 2 minus 2 3 minus lambda minus 1, and the last one is 2 minus 1 3 minus lambda equal to det equal 0. Now solving the determinant of the given matrix, we will get a third degree equation. Okay, solving the determinants, here 6 minus lambda into det of just remove this row and column, find the determinants AD minus BC. Okay, that is 3 minus lambda into 3 minus lambda minus my AD minus BC, minus into minus plus, plus into minus, also minus, minus 1. Next minus 2, minus into minus plus, minus into minus plus, plus 2 into remove the middle column and top row. Okay, using AD minus BC. Okay, minus 2 into 3 minus lambda, 2 into minus 1 minus 2, already there is a minus, minus into minus plus, that equal to plus 2, and last one is plus 2 into remove first row and the third column using AD minus BC formula. Okay, minus 2 into minus 1 2 minus 2 into 3 minus lambda equal to 0. Okay, solving the equation. Okay, so we can simplify this one. 6 minus lambda into 3 minus lambda into 3 minus lambda, that is 3 minus lambda whole square, using the formula A minus B whole square. Okay, that is A square plus B square minus 2AB. The formula is 3 into 3 9 plus lambda square, and minus 6 lambda, okay, minus 1 plus 2 into minus 2 into 3 minus lambda, multiplying minus 6 plus 2 lambda plus 2 into 2 minus 6 plus minus 6 plus 2 lambda equal to 0. And also we can also simplifying this one to convert into cubic equation, okay. So 6 minus lambda into lambda square minus 6 lambda plus 8, okay, plus here we have to simplify this one. Already 2 into 2 into 2 lambda, 4 lambda plus 4 lambda minus 6 plus 2 minus 4, 4 2s are 8, minus 8, you will get minus 8. Here also 2 into 2, 4 lambda plus 4 lambda, 2 minus 6 is minus 4, minus 4 into 6 is minus 8, okay. So now multiplying 6 minus lambda into the part of the value, lambda square minus 6 lambda plus 8, okay. So first of all multiplying by 6, 6 lambda square minus 36 lambda, 8 6 are 48, and multiplying minus lambda into this term, minus lambda cube, okay, minus into minus plus 6 lambda square minus 8 lambda, okay, and the remaining part is 4 lambda plus 4 lambda, 8 lambda, minus 8 minus 8 minus 16, minus 16, okay, that is minus 16, okay. This is after also simplifying, where is the lambda cube, minus lambda cube, okay, and 6 lambda square plus 6 lambda square plus 12 lambda square, okay, and where is the lambdas, minus 36 lambda, 8 lambda, plus 8 lambda minus 8 lambda are cancelled, okay, and the remaining part is minus 36 lambda, and the constants are 48 minus 16, that is 32, okay. 48 minus 16 is plus 32 equal to 0, okay. So after multiplying by minus sign, this will get lambda cubed minus 12 lambda square plus 36 lambda minus 32 equal to 0. So this is the characteristic equation of the given matrix A, okay. So by using calculator or any synthetic methods, we can find the roots of the given cubic equation. Cubic equation means we have 3 roots, okay. So after using any calculator, so the eigenvalues are lambdas are I think 2 comma 2 comma 8, okay. The eigenvalues are 2 comma 2 comma 8, okay. So just you can use any synthetic division method or any calculator, scientific calculator. We can easily find the roots of the given cubic equation, that is 2 comma 2 comma 8. These are the eigenvalues of the given matrix. Here 2 is repeated, okay. Repeated eigenvalues are there, okay. So now how to find the eigenvectors for the repeated eigenvalues, okay. Okay, now let's do it. Next, so here eigenvalue 2 is repeated. First, using the eigenvalue 2, how to find the 2 eigenvectors. In case eigenvalues are repeated, eigenvectors also twice. In case 2 eigenvalues are repeated, so eigenvectors are 2. There are coming 2 eigenvectors, okay. Now find how to find the, now find it the remaining eigenvectors, 2 eigenvectors, okay. Now eigenvector. eigenvector of lambda equal to 2, that is eigenvalue. Eigenvector of the eigenvalue 2. Okay. Now this consider the system of equation. Consider the system of equation is a minus lambda I into x equal to 0. X is eigenvector. Here capital X equal to x1, x2, x3 is the eigenvector of the eigenvalue. Eigenvector of the eigenvalue lambda equal to 2. Here the eigenvalue are repeated 2 times. So we will also get eigenvectors are 2 eigenvectors. Okay. Now okay, we can write the matrix A minus lambda I. Here lambda I that is so previous 6 minus 2 2, that is 6 minus lambda, 6 minus 2 2. Okay, 6 minus lambda minus 2 comma 2 minus 2 minus 3 minus lambda minus 1 minus 2 minus 3 comma minus 1 minus 2 3 minus lambda minus 1 2 minus 1 3 2 minus 2 minus 1 3 3 minus lambda. Okay, so once again you see that 6 minus 2 comma 2 2 minus 2 minus 2 3 minus 1 minus 2 3 minus 1 2 minus 1 3 2 minus 1 3. Okay, these are the system of equation, system of the matrix, and the eigenvector x equal to x1, x2, x3, and right side is, this is homogeneous linear equation. Right side is 0 0 0 0 vector. Okay, now substitute lambda equal to 2 in the above system. Okay, we will get the eigenvectors of the given eigenvalues. Okay, now substitute lambda equal to 2 in the equation, in the system or any equation. Okay, then okay, we can write 6 minus 2 is 4, 4 minus 2 2. Okay, minus 2, second row is minus 2, 3 minus 2 1, and minus 1, and 2 minus 1, 3 minus 2 is 1. Here x1, x2, x3 on the vector 0 0 0. Okay, this is the vector after substituting lambda equal to 2. Okay, so by using row transformation, it will convert into echelon form. Okay, then we will find the eigenvectors. Okay, so by using row transformation, that means row 2, we can make 0 for the rows minus 2 comma 2. Okay, by applying row transformation, that is R2 implies, so multiply by 2 row 2 and subtracting adding row 1. Okay, so 2 into R2 plus R1, and also making 0 for third row first element 2, multiplying by 2 in row 3, subtracting from row 1. Okay, that is R3 implies 2R3 minus R1. Okay, then the matrix given 4 minus 2 to 0, this will be 0, multiplying by 2, minus 4 plus 4 0, and multiplying by 2 2 minus 2 is also 0, and minus 2 plus 2 0. Okay, and in third row, multiplying by third row by 2 and subtracting row 1. Multiplying by 2, 2 to 2, 2, 4, 4 minus 4, 0, first row 0, minus 2, this is also, no, just, oh, sorry, no, here just, okay, no problem, okay, wait, yeah, 2, you can easily, to make row 3 first element make 0 by using row 2. It is very easiest way. Okay, R2 implies R3 implies, okay, just adding R3 plus R2. Okay, so okay, so okay, so using this row transformation to the above matrix is, first row is 4 minus 2 comma 2, second one is 0 0 0, third row is also 0 0 0 using the by 2 row transformations. Okay, so here x1 x2 x3 0 0 0. In case the eigenvalues are repeated twice, definitely second row and third row must be 0. So here only one row is there, that is 4 minus 2 comma 2. So the independent variables are 3, equation are only 1. So actually the rank of the given matrix is 1, but independent variables are 3. So number of independent variable is n minus r. So number of variables are 3, rank is 1, that equal to 2 independent variables are there. That is, now we can take x2 equal to k1, x3 equal to k2. Okay, find x1. Okay, that is okay. Here just write. Now the above system is get only one equation, 4x1 minus 2x2 plus 2x3 equal to 0. So equation are 1, independents are general variables are 3. So we will get 2 independent variables. Okay, now take x1 and k1 and k2. Let x2 equal to k1, x3 equal to k2 at a stake. Okay, substituting x2 and x3 in the above equation, we will get x1. Okay, that is 4x1 equal minus 2k1 plus 2k2. After simplifying, 2 2s are 2x1 minus k1 plus k2 equal to 0. 2x1 equal to k1 minus k2, x1 equal to k1 by 2 minus k2 by 2. Okay, so x1 equal to k1 minus k2 by 2. Okay, now therefore the eigenvectors x1 x2 x3 is equal to, x1 is k1 by 2 minus k2 by 2, x2 equal to k1, x3 equal to k2. Okay, now take k1 as a common of the matrix, k1 by 2, take k1 by 2 as a common of the matrix, that is 1 2 0 plus k2 by 2 as a common factor of this one also minus 1 0 2. Okay, that is, so this is the first eigenvector. This is, now take second eigenvectors. Okay, 2 eigenvalues are repeated, so we will get 2 eigenvectors. Therefore the eigenvector x1 is 1, 2, 0, and the eigenvector x2 is -1, 0, 2. Okay, so to remember that eigenvalues are unique, but eigenvalues are not unique. Okay, so multiplying and dividing some values, some independent variable k1, k2, the eigenvectors also some changes. Okay, so these are the eigenvectors x1 and x2. Okay, now find third eigenvector by using the eigenvalue. Previous eigenvalue is 8. Okay, so that is 8. Okay, now eigenvector of the eigenvalue 8. Okay, same thing. Now consider the system of the equation a minus lambda I into x equal to 0. Okay, the matrix of the equation is 6 minus lambda minus 2, 2. 6 minus lambda minus 2, 2. Next, minus 2, 3 minus lambda minus 1. Minus 2, 3 minus lambda minus 1. Okay, and third row is 2 minus 1, 3 minus lambda. 2 minus 1, 3 minus lambda, and the eigenvector capital X is x1, x2, x3. Okay, and right side is 0, 0, 0. That is it is a homogeneous equation. Okay, now substitute lambda equal to 8 in the above equation. Okay, put lambda equal to 8. We get the given matrix is 6 minus substitute lambda place in 8. 6 minus 8 is minus 2, 2. Next, minus 2. 3 minus 8 is minus 5, and minus 1, and 2, minus 1. 3 minus 8 also, that is minus 5. Okay, okay, and here x1, x2, x3, and 0, 0, 0. Okay, so in the same way, using row transformation, we can make the given matrix into echelon form. Okay, you can easily find the eigenvectors. Okay, now same thing, applying this one, first row, we can make second row first element, third row first element will be 0. Okay, so just here minus 2 and minus 2, just subtracting. Okay, r2 minus r1. Okay, okay, write down r2 implies r2 minus r1. Okay, and second row also just adding these two, rows. Okay, r3 implies r3 plus r1. Okay, we can write the matrix is minus 2, minus 2, 2. Minus 2, just subtracting, minus 2 plus 2, 0. Minus 5 plus 2, minus 3. Next, minus 1, minus 2, minus 3. Okay, and third row also just adding r3 plus r1. 2 minus 2, 0. Minus 1, minus 2, minus 3. And also minus 5 plus 2, minus 3. Okay, this is x1, x2, x3, 0, 0, 0. Okay, and next, so we can easily make zeros for the third rows using row 2. Okay, just writing r3 implies R3 minus R2, R3 minus R2, okay. Just write down minus 2, 2, 0, minus 3, minus 3. Next, this is applying row transformation, 0, minus 3 plus 3, 0. Here also minus 3 plus 3, 0. Vector is x1, x2, x3, 0, 0, 0. Okay. So we can make echelon form. So now the system of equations are getting 2. That is the rank of the matrices after using row transformation. Rank is 2. Number of variables are 3. Okay. So the number of independent variables are n minus r. N minus r equal to, that means n minus r, that equal to 3 minus 2. One independent variable is there. Okay. So already we know that the rank of the given matrix is definitely rows, number of rows minus 1. You know, characteristic equal to 0. That is it is a singular matrix. Okay. So okay, that is one independent variable. Now write the equations of the matrices. Minus 2 x1 minus 2 x2 plus 2 x3 equal to 0. Cancel 2 on both sides. That is x1 plus x2 minus x3, and apply minus sign. Okay. That is, and second row is minus 3 x2 minus 3 x3 equal to 0. So we can also write minus 3 cancel, x2 plus x3 equal to 0. Okay, this is equation 1, this is equation 2. So there are equations are 2 and number of variables are 3. So we can make one independent variable. Okay, that is, we can let us take k. Okay, now let x3 equal to k. Then when solving this equation, from 2 x2 plus k equal to 0, x2 equal to minus 2. Okay, here already we can take x3 equal to k, then x2 equal to minus k. Substitute these two into one equation. Okay, first, that is x1 minus k minus, that is also minus k, x3 also k, x3 equal to k, x2 equal to minus k. Substitute this into equation 1. x1 minus k, that is x1 minus 2k equal to 0, x1 equal to 2k. Okay. So the elements x1 equal to 2k, x2 equal to minus k, x3 equal to k. Okay. Now find all the elements x1, x2, x3. Now the eigenvector. Okay. Eigenvector equal to x1, x2, x3. x1 equal to 2k, x2 equal to minus k, x3 equal to k. Take k as a common, 2 minus 1, 1. Okay. So finally, the eigenvector 3 for the eigenvalue lambda equal to 8 is x3 equal to 2 minus 1, 1. Okay. These are the eigenvector of the given eigenvalue lambda equal to 8. Okay. So this way to find the repeated eigenvalues to get the eigenvectors. Okay. Okay. That is the eigenvalues and eigenvectors of the given problem. Okay.